Welcome to section 4.1. Today we're going to talk about finding domains of a function z equals f of xy. Now, opposed to a function y equals f of x, where the domain is going to be a region or an interval on the x-axis, the domain of a function z equals f of xy is going to be a region in the plane. We're going to practice finding the domain, and then we're going to talk about level curves and contour curves. So, the rules for finding domains have not changed. We can generalize the rules that we learned back in single variable calc to a function of two variables. The three rules are: you can't divide by 0, you can only take log of a number greater than 0, and you can only take the square root or any even root of a number greater than equal to 0. So let's just jump right in. We're going to find the domain, and we're going to sketch it, and we're going to use a solid line if the boundary is part of the domain, and a dotted line if it's not. Okay, so for this first one, what we need is x squared plus y squared minus 25 is not equal to 0. We don't want to divide by 0. So that's x squared plus y squared not equal to 25. So that describes the domain, and let's graph it. X squared plus y squared equals 25 is a circle of radius 5, and I'm dotting that in because those points are not included in the domain. What is included is all the other points in the plane. So the inside and the outside. Okay, next one, we're taking a logarithm here. So we need the argument x squared minus y to be strictly greater than 0. And that's y strictly less than x squared. So that describes the domain as an inequality. And now let's graph that. Y equal x squared is a parabola. And again, I'm using a dotted line here because the points y equal x squared are not in the domain. The only points in the domain are the y's strictly less than x squared. So that would be these points down here. Okay, a couple more. This one's pretty easy. We've got x in the denominator. We've got x plus 6 quantity squared. And so we need x plus 6 quantity squared not to be 0. So we need x not equal to negative 6. All right, and so to graph that, what I would do is put a dotted line here at x equal negative 6 and fill in the rest of the plane. Okay, and last one here, what is the surface? Let's answer that first. If I write f of xy equal to z, then what I have is z squared, I'm going to square both sides, is 4 minus x squared minus y squared. Well, that's x squared plus y squared plus z squared equal 4. That's a sphere of radius 2, but since I have square root here, remember I squared both sides, I have the top of a sphere of radius 2. All right, now what is the domain? Well, you can see from my picture, the domain should be these xy's inside that circle of radius 2. So let's just go through that. For the domain, we need 4 minus x squared minus y squared to be greater than or equal to 0. And that's x squared plus y squared less than or equal to 4. And sure enough, that's a circle of radius 2. Now this time, I'm using a solid line for this circle because those points are actually part of the domain. And since this is less than or equal to, I want the inside. If it were greater than or equal to, I would want the outside. Okay, and lastly, let's talk about level curves and contour curves. Level curves are places in the domain where the height of the surface is constant. So to find level curves, you set the function equal to a constant. A contour curve is very similar, but whereas a level curve lies in the domain, a contour curve lies on the surface. So if you look at my picture here, the contour curves are the curves on the surface where the surface has constant height. If you project those curves down into the xy plane, you get the level curves. And I'm going to show you on Calc 3D how to find contour curves and level curves, but I have a little description right here. So let's take a look at this equation here, f of xy equals the square root of x squared plus y squared. Now identify the surface and sketch it. We can do that without Calc 3D. So for part A, we have z equal to the square root of x squared plus y squared. Square both sides to recognize that as an elliptical cone. And again, since z is positive square root to start with, I'm only getting the top of that elliptical cone. So top of elliptical cone. All right, B, find an equation for the level curve corresponding to C equal 2. So what we wanted to do is set f of x, y equal to 2. That's going to give us all the points in the plane where z is equal to 2. So I've got root x squared plus y squared equal to 2. So x squared plus y squared equals 4. So that's a circle of radius 2. There we go. And for part C, C is similar to B, but it requires one more step. Find an equation for the level curve that passes through 0, 1. So on part C, we have to find C first. Don't confuse those two C's. So we have to find C. And the way to do that is to compute f of 0, 1. So C is equal to f of 0, 1, which is the square root of 0 squared plus 1 squared, which is the square root of 1, which is 1. Now we're back to this step here. We know C, so now we want to set f of x, y equal to C, just like we did before. So this requires one more step. So here we go. We've got square root of x squared plus y squared equal 1. So that's a circle, x squared plus y squared equals 1 if I square both sides, and I get that. Okay, let's look on Calc 3D. So I've gone ahead and entered the function square root of x squared plus y squared, and you can see that we do have the top of an elliptical cone. And then if I click on this, it will give me the contour curves, and I'm just going to go with the default settings here. And you can see my contour curves are circles. And that makes sense because if I stay on a circle in the xy plane, the height of the cone will be constant. And then if I want to see those level curves projected onto the surface, i.e. I want to see the contour curves, then I just click on that plot and it will show me those little rings on the surface. So that's pretty cool. Okay, let's look at this last one. This is z equal 4 minus y squared. There's a missing variable, so I know this is a cylinder. And to graph it, what I do is I look at the curve in the YZ plane, which is a parabola. It opens down like that, and up here is 4. And then I extend it along the x-axis. So there's my cylinder. And I can see the level curves in the plane should be parallel lines, because those would be the places on the surface where the height is constant. So for part B, we want to find the level curves corresponding to C equal 2. So I set f of xy equal to 2. So 2 is 4 minus y squared. So y squared is equal to 2. And that gives me two curves, y equal plus or minus root 2. If I wanted to graph those in the xy plane, that would be this curve and this curve. Up here is root 2. Down here is negative root 2. And this is y and this is x. All right, and for part C, there's one extra step. I need to find C, and C is going to be f of 0, 1, and that's 4 minus 1, which is 3. So now I'm going to set f of xy equal to 3. So that's 4 minus y squared equals 3. And if I move things around, that's y squared equals 1. So I get the two curves y equal plus or minus 1. Okay, and that's the end of this section. There is some more reading if you're interested on topology on the last page.